Wonderful. Well, thank you everyone so much for being with us today. We really appreciate your time on this warm, kind of springish day. So thank you very much. My name is Emily Thompson. I'm the Director of Operations for New Hampshire Healthcare Workers for Climate Action. Today, we're really honored and pleased to be co-sponsoring this webinar with the New Hampshire Network Energy Working Group. So thank you so much to Susan Richmond for all of her work coordinating this with us. And we're glad our groups can collaborate. I'm going to go ahead and start this webinar with a land acknowledgement. So this webinar takes place on Indokina, which translates to our homelands that is now called New Hampshire and Vermont. Indokina is the unceded traditional ancestral homelands and waterways of the Pennacook, Abenaki, and Wabanaki peoples, past and present. We acknowledge and honor with gratitude the land, water, air, flora, and fauna, and the human beings who have stewarded Indokina throughout the generations for over 12,000 years. I'm now going to introduce our moderator for today's session. We have Dr. Paul Friedrichs. He's a retired family doctor in New Hampshire, and he's currently serving as board chair of New Hampshire Healthcare Workers for Climate Action. So, Paul, I will pass it over to you.
Thank you, Emily. We're excited to have Paul Bemis here today to talk about building codes, your health, your wallet, and energy efficiency, and see if we can tie that also into some of the challenges of climate change and climate's impact on health. Paul is the president of Granite State ASHRAE, which is the American Society for Heating, Refrigeration, and Air Conditioning Engineers. He's an expert in building science and has been working in the field of energy efficiency in the built segment for over 30 years. He is himself a mechanical engineer with a degree from UNH, an electrical engineer, and then having an MBA, I believe both from Northeastern University. And he's currently owns a software and consulting company in New Hampshire. It is a top supplier of thermal modeling software and services for the mission critical data center market. So Paul Bemis, please, thank you. Let's start. Oh, could you hold your questions to the end, please? You can enter them in the chat and we'll have a question and answer period at the end. Thank you.
Thank you, Paul. I'm assuming everyone can see my screen now. So yes. Is that okay?
Yep.
Great. Thanks for that nice introduction. I'm going to get right into it, and I'm going to talk about first who ASHRAE is. They're about 50,000, 60,000 members, 103 countries. The way that they relate to building codes is the ASHRAE is the organization that does the research on building science. They're the ones that work with the national laboratories to create the models, to do the analysis, to do the work, to do the reference homes, and therefore come up with the recommendations that eventually become codes. So the energy codes themselves are an outgrowth of the work ASHRAE does in its research area, and we fund that through a variety of mechanisms. I'm the president of the local chapter, State of New Hampshire chapter, and I try to bring that knowledge to those of you in the state and try to be a bridge to the national organization. That's how that works. There's about 150 members in New Hampshire alone who are all in the field of building science. Just a little bit of level setting here with respect to energy consumption. This comes out of some work done by National Institutes of Science and Technology. You can see here that if we take a look at energy consumption, you can see that in terms of buildings where residential and commercial represent the largest section of energy consumption. It's larger than transportation. Combined, it's even larger than industrial consumption. So, you know, we talk a lot about carbon emission and climate change. The largest emitter of carbon emission is buildings. And essentially, they're just leaking it out. Now, you have the issue of burning a fossil fuel. Combined with that, most of them are heated by fossil fuels today. So that there's that issue. But also the fact that they're leaking so badly. Our building stock in the United States is very old and leaks terribly. So if we want to address climate change, we have to go after buildings. They have to be a component of that. In terms of what goes on in a building in terms of energy consumption, you can see here that most of it is space heating. You know, a third of it right now is space heating. And it's not very efficient to do that. Then we have, of course, cooling. So heating and cooling are the two big ones. That's always the biggest chunk, followed by water heating. So there you have more than half of the consumption in the building is going to space heating, water heating, and cooling, depending on the situation. So it's big, and there's a larger opportunity to address that. And there's money becoming available to address it too, because we all are pushing on the same issue, which is carbon emission due to, in this case, buildings. Now, I've been working with the Hampshire legislators on this. There's a few bills I'm going to reference today that are currently being discussed. I actually testified on both the House and Senate on this topic a couple of weeks ago. There's House Bill 1059, which is originally designed to adopt the entire 2021 ICC code, which would include energy, but they held out the 2021 ECC, the energy part of it. The bill as it currently stands would only keep the 2018 version of the energy code in the ASHRAE, and everything else would be 2021. So the structural component, all of the fire safety, everything would be 2021 except energy, kind of the most important part from at least my point of view, and they're going to hold it out. So we tried to put an amendment on the table to bring the 2021 energy code in. It was defeated. We didn't even get a motion on it in the subcommittee, to be honest. It was defeated. So, you know, we'll talk more about where they stand towards the end. The SB 373 would adopt the entire 2021 code as well. That was a kind of a duplicate bill because the House had a similar bill, 1059. So they scrapped 373, and 1059 is the main one now. There is a third one that's important too, 437. That's this last one. This one is quite important because this one says, as it's currently written, that this would not allow any town to have a more stringent code than the 2018 code. Now, there's been an amendment to that one, and that has been rectified through the amendment, and it's going along right now. We don't know how it's going to turn out because we're still in session. But this one, when in its original form, which I testified against, would not allow a town to have a more stringent code, even if it wanted to. And there are towns who have more stringent codes, like the town of Durham, for example, has a more stringent code than the state code. So that's some of the bills that we're talking about in this session. And I wanted to spend the opportunity to talk about why you would want to go to the 2021 codes. Let me start with energy efficiency. There is the argument that's being made right now. Is my audio working all right? Yes.
Yep.
Yeah, okay. So there is this perception that the upfront cost is going to be higher, and therefore, you know, let's keep cost of buildings down, cost of new buildings down in particular, because these codes are most related to new buildings. And so many people in this area ring that bell of increasing upfront cost and use that as a cudgel to keep these codes from being adopted. However, it's really just cost shifting. I mean, the issue is the buildings should last for at least 50 years. So if you don't spend the money up front on things like insulation, which is what this bill is really about, insulation and vapor barriers, then what happens is you pay for it in the operating cost. So it's either pay me now or pay me later. You're shifting the cost out of upfront into operating cost. And that tends to play out over the length of the building. And essentially, you're shifting a burden, a tax burden or a cost burden onto the operator. Now, the operator is often not the person who purchased it. It can be a leaseholder, for example, or a tenant, for example, who's paying higher energy costs because the building wasn't constructed correctly in the first place. So it's really, you pay me now or pay me later. It's better to do it up front. By the way, if you do it up front, it's lower cost because Trying to do insulation after the fact is extremely expensive, typically an order of magnitude more expensive. So imagine trying to insulate a slab under a building once it's already poured. How do you do that? I mean, you really can't do that. So if you don't do it up front, it becomes extremely expensive to do it later. We all know this because many of us are living in older homes, and to get in there and re-insulate them and to do the work is extremely expensive. The second issue I want to talk about is human comfort. Comfort is something that is very quantifiable and measurable. We know what human comfort looks like. We know the parameters of human comfort. They tend to be things like humidity and particle count and oxygen, carbon dioxide count. We know exactly thermal temperature. We know exactly how to make humans comfortable. And this has been known for quite some time. So improving human comfort would also come from a more efficient home. Specifically, we've seen in schools, for example, when the building is well insulated and there's a proper vapor barrier in it or on it, then the students are much happier. Everybody's happier. It's quieter. The thermal condition is more even. It's not cold in one area, hot in the other. And the humidity is sufficient so that human health is improved. The other point here is that the property value goes up. Now, this is something we've been stressing for a number of years, that if the dollar per month for an energy efficient home is lower in terms of energy cost, then the value of the home ought to be higher. And in fact, that's coming to fruition. We're seeing that on average about 2.7% price premium on energy efficiency homes. That's Sally May's number. So they're beginning to realize in the market that these are worth more money. Furthermore, lower interest rates for energy efficient homes as well. So the upfront cost can be offset by improved market value if you were to sell it, and or lower interest rates. That doesn't include any energy subsidies, which can be applied for as well. And then finally, of course, related carbon emissions, a reduction in related carbon emissions. So these are the four primary things I speak about when I talk about why you would want to move to a more efficient energy code. Let me go through a couple of them. Let me go through a couple on human health, for example. We know that it's quite good to have particle counts, small particle counts, particularly PM2.5. This was very obvious during COVID. You want to have low particle counts. A particle count, this is PM2.5. These are submicron, 2.5 micron or less particles. We measure this for outdoor air and also indoor air, and you really want them to be low because it's the small particles that pick up the pathogens that transmit anything from COVID-19 to a common cold. It is the particles that carry it predominantly, not surfaces. This is something that we learned in spades during the COVID pandemic. Also, CO2. This is an indication of oxygen in the environment, and you want the CO2 count to be below 800 is really where you want it to be. So 0 to 700 is good, a little over 700. And as these things go up, it becomes a very unhealthy environment. So these are two parameters we look at a lot inside of buildings. And if we look at humidity as another parameter, humans operate best in the 40 to 60% relative humidity range. This is a plot done by a study that looked at a large number of cases, thousands of cases, and found that in the 40 to 60% relative humidity range, the infection rate just drops tremendously. That if we have proper humidity, our respiratory systems are more able to fight off infection. Very hard to hold humidity, by the way, in the state of New Hampshire in the wintertime without a proper vapor barrier. So if the house is not sealed, the moisture will just be sucked out. If any of you have tried to put humidity into your homes and then put a humidistat up and watched it, I've done this myself, almost impossible to get the humidity up in a home that leaks. The vapor barrier is extremely important. It's unglamorous. Many of the things we're talking about here are not glamorous. These are not high tech. We're not talking about advanced technologies here. We're talking about insulation and vapor barriers being very, very important to human health. This is another plot, different study, but I could show you a lot of these. This is, again, we're taking a look at relative humidity, and we're seeing a tremendous drop in relative humidity when the percentages are between 40 and 60. And if you want, I can give you references to these cases. This information was presented at one of our ASHRAE webinars by Dr. Stephanie Taylor, who's worked in this field for many years. She's both an architect and also an MD in studying the effect of human health correlated to relative humidity. Humidity is quite important, and study after study, this is yet another one, 2018, they took a look at classrooms and they found that, again, with relative humidity being in a certain range, you're going to have between 40 and 60, you're going to have much lower illnesses. So here we have 9 at 45% relative humidity. We have 22 at 20% relative humidity. And they're airborne. Now, there's a couple of reasons for this. One is that when these small particles dry out, they float. They become buoyant and they ride on thermal currents in the room. So there's more of them floating. They're not heavy. They don't fall to the ground. They float, and therefore you ingest more of them. And the thing about our human physiology is that these airborne pathogens that float through the air are typically caught in the upper sections of our respiratory system. And so when you cough or sneeze or even talk loudly, particles come out. You can actually see them. We've got video of them coming out with high-speed cameras. You can visually see these particles coming out. And when we were in the COVID period, we did a lot of research in this area and filmed it. And what happens is we have this mucus that is in our respiratory system, and it flows upwards. This is when you clear your throat, you're bringing it up and clearing it. And there's a barrier there that, and these little cilia that ride right here protect our lungs from infection. It's the first line of defense. And it also produces a couple of different kinds of cells, the macrophage cell and the dendritic cells, and these help to fight off this infection. But as the relative humidity declines, these dry out. And when they dry out, you're missing this entire defense mechanism. This is why in low humidity situations, you tend to get sicker. It's not surface. Many people for years have thought it's surface. It is not, although I'm not advocating we don't clean surfaces. It's important too. But what we're finding is that a dominant amount of this is caused by particles and the fact that our immune systems are compromised due to low relative humidity. And the only way to keep the humidity in an environment is through proper vapor barrier. Back to the codes, one of the things about the 2021 code is improved vapor barrier. So there are 2 primary things in the 2021 code that are important. One is better insulation, so that we don't require as much energy to keep our homes or buildings warm or cool. The other component of it is humidity, so that we can keep the environment with between 40 and 60 and therefore reduce the amount of airborne pathogen illness that results from it. So, at 50% relative humidity, between 40 and 60, again, things just work a whole lot better. You see decreased inflammation, enhanced protection, the cilia are working, everything works quite well. So a few points to make, and then I'll open it up for questions here, because I don't want to take all the time going over a bunch of technology. I want to be able to make this a discussion. But from a science point of view, from a building science point of view, there's no good reason for delaying these. The argument about upfront cost is not really valid. Even the study that was done by the Home Builders Association, who is lobbying against this adoption, is showing that it's a few $1,000s. The biggest number I could see was in their study was about $7,000 to implement the 2021 codes over the 18 codes. Well, as a percentage of sale price, that's a few percent. It's not that big a number. And if you're going to lower the per monthly charge associated with electricity and heating fuel or whatever it happens to be, then you're going to pay for it. Most studies, most analysis done by the national laboratories are showing a payback period of 3 to 5 years typically. So there's not a good economic reason for it. And what it will do is reduce the energy consumption and cost for building owners and leaseholders and anyone who is attending those environments will have better human health and comfort, thermal comfort. These environments tend to be quieter. They tend to be, from an education point of view, we've seen improved cognitive response. Actually, that can be measured. One of the national laboratories did that. That was Lawrence Berkeley Labs did a big study with the state of California and found that cognitive response improved when the environment was healthier, which means better air in terms of oxygen and also lower particle count and better relative humidity. It also increases the value of the building or home in the market. It's not just me saying it, but the national organizations like Fannie Mae and Freddie Mac who loan money and set these prices are arguing this. They're not the only ones. It allows for more deployment of energy efficient heating and cooling, heat pumps being the best example. Just to give you a brief insight on a heat pump, remember that a heat pump just moves the heat from one location to another. It either takes it from inside your home on a hot day and moves it outside, or vice versa, when your home is cold, it takes it from the outside and puts it inside. A common example of a heat pump is your refrigerator. It takes heat out of the storage compartment and puts it in the room. That's why it's always warm near your refrigerators, because it's dumping heat to the environment. The ones for our homes are just reversible. You can switch them so they can become both a cooling device and a heating device. Now, in comparison, most of us use fossil fuels to heat our homes today. And we use natural gas or we use oil are the two dominant ones in New Hampshire. Now, if you're lucky, the efficiency of your heating system is, if the home is not brand new and the system is not brand new, the efficiency of them is about 60 to 70%. That means that for each unit of energy that you are burning, you're only getting about 60 to 70% of it going into the room as heat. Obviously, they can't cool, so all they can do is heat. The rest of it, you might as well light a match to it because it's simply going up the chimney. It's going away. In contrast, if you put a heat pump in there, that same unit of energy, we'll call it 1, by the way, you only got 60% of it a moment ago, that unit of 1 will now give you 4, at least, units of heat out. In other words, the improvement is at least a 4 to 1. So if the energy costs were the same for home heating oil as it were for electricity, then you would get more than a 4 to 1 advantage out of a heat pump compared to a fossil fuel, and you get cooling with it. So heat pumps are becoming extremely popular for that reason. It's simple economics. It just makes sense. The other point is energy form of electricity is much higher. It can do many, many more things than fossil fuel. The only thing fossil fuel can do is heat. It can't really cool, where electricity can provide lighting, can provide cooling, can provide hot water, can provide a lot more, can power your computer, can power these meetings that we're sitting in. So it's a more advanced form of energy, a higher level of energy than fossil fuel would be. Now, in order to make heat pumps effective, or any really, you need a good building envelope and a good vapor barrier. The other thing is, if the home is efficient and has proper insulation and a proper vapor barrier, then it reduces the demand on local transmission and distribution. A lot of concern about, can the grid keep up? Can electricity, is there enough? And it is true that if we move to EVs and we move to heat pumps in our homes for heating and cooling, it's going to require 60% more electricity. That is true. However, you can generate a lot of that locally. So the idea of local transmission distribution through solar and other sources is something that can offset that. Furthermore, if the house is efficient to begin with, then it just takes a lot less energy overall. There are two components of this. The one is the demand side and the other is the supply side. On the demand side, our homes can be reduced in terms of energy consumption a great deal through better insulation and vapor barrier. These are the things that are in the 2021 code. So this is why I'm an advocate for it, because it helps in a variety of areas. The last one being greenhouse gas emissions from the largest sector of the market. If we're serious about climate change, we have to go after buildings. They're the elephant in the room. They're the big consumer of it. They're not the only ones, but they are big. And we have to have a strategy for addressing this particular sector. And the 2021 codes move us in that direction in a very big way. So we have a situation where, there's been a group, the National Association of Home Builders, has produced a report that has a conclusion that says the return on investment is not worth the upfront investment, and it's fundamentally flawed. I've reviewed the study in quite a bit of detail. I'm an energy modeler. My job is mathematical modeling. My company is called Applied Mathematical Modeling. I know a lot about this topic. The study was not done very well. It looks like it was done with a predetermined conclusion. For example, they use natural gas as their energy source. They use natural gas in the year 2019, I think, as their cost of energy. We don't use a lot of natural gas in New Hampshire. We use typically oil and LP gas, which tend to be more expensive. But, the legislature seems to be willing to accept this false conclusion, and there's a strong lobby by this organization. It's a national organization, and we're not the only state that is complaining about this. I've read reports recently about this same issue happening in other states. So it seems to be a national movement. I don't know exactly what's behind it. SB 437 has been amended and passed by the Senate. So it looks like if it passes final muster, we will be able to final vote, which is coming up, I believe, next week. We should be able to have a code in our own local town that exceeds what the state ends up with, which would be the 2018 codes. And I would encourage you all to push for 2021 energy code compliance in your local town and municipality if you possibly can. So that's really it. I will open it up for questions here and take any questions that I can answer.
Thank you so much, Paul, and thank you for your work with ASHRAE. It's really impressive to see how far building engineering has come in the last 50 or 60 years. I grew up in old housing stock in New England, Victorian buildings, colonial buildings, and it's so important that we apply this modern engineering science to our buildings at this point. Can we go to the full screen so we can see each other? Thank you. Yeah, certainly we at New Hampshire Healthcare Workers for Climate Action feel that the fossil fuel emissions is has such a big impact on human health, both the act of burning the fuel now, but also, of course, the impact as greenhouse gases on our climate. So we're 1,000% behind the efficiencies and the reduced greenhouse gas emissions with better insulation. But we're also concerned about, other health impacts of our indoor environments. 92% of the time, Americans spend 92% of the time indoors. So indoor air quality is critical. And your data about that sweet spot of relative humidity between 40 to 60% is so critical for respiratory infections. That's been attributed why, influenza rates in general go up in the winter because of the drier air. But not only those respiratory viruses, but mold is, of course, tremendously impacted by humidity, and also dust mites thrive better on higher temperatures and higher humidity. So
yeah, that's right.
I guess I'd like to open up the question by just asking about how we get to that sweet spot of humidity, 40 to 60%. You mentioned the critical role of modern quality vapor barriers, but how do we also add humidity when we need to? Does the vapor barriers just naturally do it, or do we have to? Should we be monitoring of the humidity in our homes and adding water in the winter when it tends to be drier? And certainly with the climate change we're seeing, in my house anyway, was built without central air conditioning. We felt that just opening the windows and airing things out through 2 or 3 seasons of the year was the way we modified the temperature. In the summer, we open up all the windows at night and close them down when the sun comes up to keep the cool air and what have you. But we found this year that we had a mold problem in our entry room for the first time ever, a west-facing window and door. We never had mold where we hang our coats before this past summer, and it became a problem. So we're going to be adding upstairs dehumidification to our downstairs basement dehumidification, and thinking about adding HEPA filters for the first time. So what else do we need to do to supplement our vapor barriers to hit the sweet spot of humidity on our homes?
It's a tough problem, and the answer is proper sealing of the home, or the building, and it's not glamorous work, but it's important work. So what you're facing in your situation is the lack of humidity in one case and the abundance, too much of it, in the other case. So once you get above 60, you do run into issues with mold. And mold will often occur when there's a rapid thermal gradient and you've got rapid change in temperature and you've got moist air. So let's say the summertime, when it's a lot of humidity in the air and it comes in contact with something cool, it will hit a dew point and create mold. If there's a proper barrier or piece of plastic, I'll use that. Vapor barriers can be done with plastic. It's the easiest thing for us to think about. If you had a seal around the building, that would not occur because the moisture can't go through the plastic. So vapor barrier is really important. Now, if you don't have a proper one, and I can tell you don't, Paul, because you're exhibiting these problems. So the only thing you can do is try to put humidity in the air. To do that, you need to get a humidifier. I have one in my home, by the way. Mine's much like yours, probably a little tighter, but we put humidity in the air. You can buy a portable humidifier and turn it on, particularly when the temperature drops down below 20 degrees. You need to put humidity in. Now, it won't stay because water has this tremendous affinity for going from wet to dry. So it'll pass through most things like sheetrock and wood and walls and all kinds of things. But nonetheless, you need to put it in there. Otherwise, you do run that risk. The other one you mentioned is mold. It's often caused by an improper thermal barrier, because what's happening is it's the moist air is coming in contact with cool air, and that's hitting a dew point, and then you get mold. So the two go hand in hand. You need proper insulation, a lot of it, the more the better. You cannot over insulate, and a proper vapor barrier. Now, with respect to oxygen, some people say, and someone would raise this in the legislature, well, can a house be too tight? The answer is no. Now, you used the example, Paul, of opening the window to ventilate. The way we do that in building sciences is now with an energy recovery ventilator. So the way that works is it's, instead of opening the window manually, you have this box. They're fairly simple and they're not that expensive. A box where air goes out one side and fresh air from the outside comes in the other. But what happens as the air is leaving the building, it will go through a heat exchanger where the heat or cool, depending, remember, heat goes both ways, up and down. So the warm air will be captured by the device, usually through a ceramic piece of material, and be introduced to the air coming in. So the temperature loss is very low, unlike the case you described where you open the window and you get quite a bit of temperature change. Here you would get fresh air without paying the penalty in temperature. The temperature difference is really quite low, only a few degrees. And by the way, these things are extremely efficient these days. So we ventilate the building mechanically using an energy recovery ventilator. And that's how you get the oxygen up, the CO2 count down. Moisture we do through proper vapor barrier and building insulation. Again, these are not very exciting things. There's no big technology here that I'm talking about, but they are fundamentally important to good human health inside of these buildings.
So a follow-up question is, in terms of efficiency and energy savings, is it best not to be opening our windows, but to have a built environment that really modulates it through the ventilation you described?
The answer is yes. It's better to do it through a mechanical energy recovery ventilator. And the reason why, Paul, is the one you talked about with respect to mold. Because if the air outside is moist, I've made this mistake myself. My basement's cool, so I wanted to warm it up one year. So I opened the basement windows. The moist, warm air came in, hit the cement floor, and turned to water. So it condensated. That's the problem. When that warm, moist air comes into the environment and hits a cool surface, such as a basement wall or a floor or something, it tends to hit a dew point. The dew point causes, of course, moisture, which turns to mold. Mold cannot grow without moisture. If it's dry, it cannot grow. It does not exist without water. So if you keep it the right humidity, you won't get it. But if it raises above 60%, then it'll happen. Now, the trick is, Paul, opening and closing your windows at just the right time. But you'll have to stay up late at night in order to get those open and closed correctly, you know, because it often happens in the overnight.
The other health issue we're concerned about with tight buildings is radon. So if we have tight buildings, we have to monitor that and take care of that. Is that not correct?
That's true, but again, mechanical ventilation will do that for you, right? Because you want, in buildings, you want an air change rate, and people get confused about air change rate. Let me define it. Air change rate is the total volume in your house being exchanged for clean, fresh air, okay? Now, you can do that a couple of different ways. A HEPA filter will do that for you. It's not going to introduce oxygen, Paul, but it'll certainly get all the mold spores and all of the small particles cleansed and cleaned. And, you know, portable HEPA filter is a very positive introduction to any home environment, by the way. But the issue of something like radon, you need to get fresh air in. And fresh air comes through introducing outside air in, but it has to be, of course, the right temperature and humidity. And you have to do that through a device. Doing it by hand is difficult at best. You can do it, but it's challenging to get it right. In general,
sorry, go ahead.
In general, our buildings are becoming more sophisticated. They're becoming a system. You know, it used to be that they were just 4 walls and some windows and all. Now, as we try to drive for more energy efficiency, they are becoming more sophisticated, more of a system. And as a result, these things do need to work together.
Of course, one of the concerns about a tight home that has this ventilation, as you described, maybe windows that don't even open, is then power outages and what happens to the air exchange and what have you when you don't have those systems working.
Well, solvable problem. So here's from a building science point of view, where we want to go with buildings is rooftop solar and storage and heat pumps. So that if the grid goes down, you have some time that you can continue to operate in these environments. I mean, batteries will be good for, 4 hours is a normal period of time, 4 to 6 hours that you can run on straight battery. As these homes get more intelligent, the opportunity to put solar with battery and let the home be responsible for a lot of its own energy. This solves a couple of problems. It solves the demand issue that we talked about earlier, where as we go to electrification in the home, the demand on electricity will go up by, that's estimated to be about 60%. How do you account for that? Well, one way to do that is to use solar plus battery, which is becoming a more attractive opportunity every day to compensate for that. By the way, as we buy electric vehicles, we're moving in that direction anyway, because with the electric vehicle, you get a battery. So the batteries are coming along as part of our transportation solution. Coupling them to solar on the home is a future that we think is obvious and will happen. The question becomes, how quickly will it happen? Will it happen in time for us to save the planet? That's the question.
Those are great recommendations. Turning to the chat, Diana asks, what is the average cost of installing a heat pump for a single family home?
About
My
$10,000.
follow-up question to that is if we're building new structures, should we be thinking about going straight to geothermal? Isn't that a even better solution in the long run?
Well, about $10,000 is what it would cost to install a heat pump. That's a pretty short answer to that one. It's right around that number. It might be a little more, a little less, depending on the variation, but 10's a fair number to keep in mind. And it will pretty much handle your home. Now, my sister owns an old home. It is fairly well insulated because she did some renovations to it. Installed heat pumps have been running fine all winter long. Every once in a while, she clicks on the old furnace just because it's 10 degrees out and she wants to add a little to it. But for the most part, been very happy with them in a northern town here in New Hampshire. So they are effective. The question of geothermal is just an issue of where do you get the heat from? There are two kinds of heat pumps. One's called an air source. They're the most common. They're pulling the heat out of the air. So even on a 10-degree day, they're pulling heat out of the air and putting it in your house. Those are becoming quite efficient. They're running now into the 0 range in terms of temperature and still maintaining a positive efficiency. So air source is less expensive always. The reason is with geothermal, you have to drill a well and put the loop in the hole, and that means drill a well, which is at least another 10 grand, or you have to lay the pipe in the field or the ground, which means you have to trench it, put in a link, a tube, or a loop of water or glycol to pull the heat out of the ground or put the heat in the ground. Tends to drive up the cost. So the lower cost solution is air source, and the higher cost solution is geothermal. From an energy efficiency point of view, geothermal is better because it's just more efficient. Remember, the Earth is 50 degrees. It's easier to get heat out of 50 degrees than it is to get heat out of 10 degrees in terms of just moving it, pumping it, but the upfront cost is higher. An elegant solution is geothermal. More practical, cost-effective solution is air source heat pump.
Great. Catherine asks, what do you call the air exchange device that you were describing, so she can look it up?
It's called an energy recovery ventilator, ERV, energy recovery ventilation. There's a variety of them that are made for residential and commercial accounts. We just installed 3 or 4 of them at a elementary school in Ashland, New Hampshire. They're rooftop units that run that way, and but there are also ones for your home that you can install and run. And again, really what they do is they exchange the air with outdoor air, and during that process, they extract the heat or cooling. Remember, on a cool day, you don't want to open the window because it's hot outside. So as the air goes through this device, the coolness is extracted and supplied to the incoming airstream to cool it down before it enters. So you get the benefit of fresh air without the downside of opening the window and letting all the cool air go out.
Great. Tom from Rye asks, our town only requires blower door and duct test results upon completion to get an occupancy certificate. Is requiring an energy modeling report certifying compliance with the entire IECC allowed by Senate Bill 437?
It's an energy model is not required, no, but blower door testing, it should be required. By the way, there's in both of these bills, they've excluded commissioning. The state of New Hampshire does not require commissioning at all. Commissioning is the idea of testing the building to make sure that the builders built it according to the specs that you handed them or that they were supposed to comply to. We don't have any commissioning requirement in the state of New Hampshire. It's another fight we're having with the legislature. We believe there should be commissioning. Commissioning ensures that you get what you paid for. And without commissioning, you never know. Now, the case that you just described, the fact that the town's requiring blower door tests is quite good, because that is one of the things you do during commissioning. Let me describe it. What they do is they put a fan on the door. That's why they call it a blower door. They actually put a fan, they open the door and put a seal with a fan in it to pressurize the house. So this is the idea of blowing up the balloon that may have a bunch of holes in it. Most homes do have holes in them. Blow up the balloon and measure the amount of air that's leaking out of the holes. And there's a number for that. For example, in the 2018 codes, it was only 3 and 5 air changes. And where we want to get to is 3. We want less leakage. So the code is stricter on the 2021 side than it was on the 2018 because we're trying to get the building tighter. That's what a blower door test. It measures exactly how much the building is leaking. Why is that important? Well, A, thermal, if the hot air leaks out the holes, that's not a good thing. And B, vapor barrier. If you don't have a proper vapor barrier, then you're not going to be able to hold the humidity. So it's important for those 2 points, and not enough of it is done. You can get an energy audit of your home, and sometimes New Hampshire Saves will help pay for that, depending on your income sort of level. But blower door testing gives you the first analysis, the first indication of how badly your home is leaking. So, Paul, I recommend you get one for your home and find out what your air change rate is. It's called ACH, what your air change rate is. I mean, 2018 code is 5. We're trying to drive it to 3. By the way, passive house, 0.6, right? Passive house specification is very stringent. And that is driving towards net zero. In other words, no requirement or very little requirement for energy and net zero. And passive house defines that at 0.6 air changes per hour. Yep.
So, but could the town of Rye go even further and require a energy modeling report in addition to the blower or beyond the blower test?
I hope so. But again, there's a Senate bill that we hope will pass that we made modifications to because originally the Senate bill was written. This is Senate Bill 437 that said local towns did not have the right to have more stringent codes than what was set by the state. But that has been modified. We're hopeful that the modified version will pass. We got to get it by the House. But again, we're expecting pushback from the Home Builders Association claiming, first cost. They're always claiming first cost. It drives up the cost. But again, all the other benefits are there. Thermal benefit, low carbon footprint, better energy efficiency, lower health bills, better human comfort, better health outcomes. So I think the pros outweigh the cons from my point of view.
So Bruce from Pittsfield asks specifically, about the status of these bills. What can we do to make sure that the right bills go through and the wrong bills don't? Do we know what the status of and what the timing is for feedback on these? Anybody on the Zoom know about that or can chime in?
What I do know, and I'm working with Clean Energy New Hampshire on this, so I'm working with Chris Scotland on this, but I mean, I'm hopeful that the modified version of 437 will pass. I don't know what we can do about House Bill 1059, which holds us to the 2018 codes. I testified in a subcommittee and couldn't even get a motion on the table to consider the 2021 version of the energy code. So I mean, you have legislators in your geography. Talk to them. I'm certainly doing that myself. So educate them, I think, is all we can do is continue to push.
Susan, do you want to chime in on this?
Yeah, I made a slide at the end that I'll show. The problem is that a lot of things happen on Thursdays and none of it is being reported yet. None of the bills are dead. So they've done whatever they've done in the House. I'll be more specific when I've got the slides in front of me, but they have another chance in the Senate or vice versa. But what's been especially nice is Chris gives us information and we've been really noisy about it, and New Hampshire Network members have evidently been weighing in quite a bit, and the builders all thought that it was just a slam dunk, and suddenly there's an awareness of, hey, this might not be a good idea. So write letters, and you'll see that in the final slide, what bill what, but write letters to your own representatives saying, when it comes to the vote in the full House or the full Senate, please insist that the most current energy bills are included in the bills. And I'm wondering, Paul, if Gabrielle Watson could talk a minute, because she's talking about the larger national political scene that is bringing this builder situation to us.
Absolutely.
Yeah. So Gabrielle, do you want to talk about your comment about the national effort?
She told me earlier she had to go to a select board meeting because she's advocating
Oh.
advocating for energy efficiency in her town. So she may not
Okay.
be with us at this
Well,
time.
There is a
it's
reference.
right up there in the chat. So anyone that wants to read, and I've read articles about it as well. There was one in the Washington Post that this is yet another issue that's part of a national playbook, that in this case, the gas industry doesn't want us being efficient, doesn't want us using less gas. So
It's a common theme. We will need to work together to overcome the resistance by the fossil fuel industry for change. And they use scare tactics like first cost, to make their points. So we need to try to counter that, because it's not in our best interest as humans. I mean, Paul made the point, we spend more than 90% of our time indoors, well more than 90%. This is important for us, for human health, to have a good indoor environment. And not only is it good for our human health, it is good for our atmosphere, it is good for our globe, it is good for our wallets. I don't understand the resistance other than vested interests in fossil fuels and related profit.
Vested
Paul,
interests in-
perhaps one issue that probably resonates really well is the builder saying, well, we can bang out housing faster because there's a housing shortage. So do you want to talk to that?
Yeah, I know. Well, remember, whenever you're manufacturing something, such as homes, that's what they do. They're manufacturing homes. Your profit is correlated to margin times the number of units you produce. So if you can produce them faster, you make more money. So it's natural that they would say that, because there's more money in it for them if they can do them faster. But if they're not energy efficient, the responsibility for paying the energy bill gets dumped onto the owner, oftentimes unknowingly, because it's unusual that a homeowner will know about these topics. They're not building scientists, and the home builders will say, well, they're not asking for it. Well, yes, people didn't ask for handheld calculators before they were developed, or personal printers before they're developed. You have to educate the audience that this is important, and it's part of why I'm here today, is to try to help educate, because again, it's simply a cost shifting. I don't believe there'd be much difference in time. The materials are a little different because you have thicker insulation on the ceiling, but much of this is just related to the way that they're doing the implementation and the requirement to do it with a little more focus on a couple of areas, such as insulation and vapor barrier.
We're getting close to the end of the hour, but if I could throw in one last sort of change of the topic a little bit, is that, in New Hampshire, the climate change we're seeing is towards a warmer and wetter climate with higher incidence of extreme weather events. So to what degree should our regional building codes take into account these extreme weather event possibilities, and does that need to be tightened up a little bit in terms of building for floods and things like that?
Well, again, it argues for the same solution. Let me hold floods aside for a moment, because that's a tough one, right? But if we're talking about rapid change in the climate, for example, again, if the home is well insulated with a good barrier to the outside, then we call it ride. It has more ride time. In other words, the indoor environment won't change much while the temperature dips. This is really important for schools, for example, that and buildings of all kinds, that you get this opportunity for a thermal ride where the indoor environment stays constant regardless of the rapid change of the outdoor environment, because you're essentially insulated from it. You're insulated from it from moisture, and you're insulated from it from a thermal point of view. And driving those two parameters up is going to give you better resiliency in climate change. Furthermore, we talked about heat pumps and the efficiency of heat pumps. Heat pumps give you both heating and cooling. Fossil fuel only gives you one. So with cooling, as our environment changes and we need more cooling, the heat pump will deliver that to you at a ratio, as I mentioned, of at least 4 times more efficient than you would get from a fossil fuel, which would only do one of them. Flooding is a tougher problem because that requires better drainage and outdoor environment, for example.
And lastly, but not least, with the concern about infectious agents in our air and optimal humidity points, what have you, should we all have HEPA filters in our homes?
I argue yes. I started building HEPA filters, manufacturing HEPA filters during COVID because we needed them. Now there's a lot of them available out there on the market today, and we had a tough time competing against the Chinese. But the HEPA filters I've installed into homes, I've gotten tremendous positive reinforcement from people who have them, because it simply reduces the particle count. It reduces the pathogens. It reduces allergens. It reduces mold spores. It takes it all out. Our lungs were not evolved to be able to handle an indoor environment very well. We evolved outdoors. We're used to outdoor air. And so being exposed to pathogens at low humidity is a compromise for our health system. If you contrast it to the digestive system, it's pretty stark. The digestive system has evolved over many, many millions of years, where the lungs, because we've only been inside since roughly the Industrial Revolution, our lungs are not well equipped to defend against airborne particulate pathogens that cause allergies and respiratory issues, particularly at low humidity.
Great. Well, thank you. We're going to wrap it up and pass it on to Susan to tell us more about the upcoming New Hampshire Network events. And as she's pulling up her slides, I'll just mention that New Hampshire Saves this week and maybe beyond this week, but right now they're having a special on HEPA filters where you can order it through their website for 50% off. So check that out if you're interested in a HEPA filter. I just ordered one yesterday.
Wow, great information. I'm ready. I want to just say not only huge thank you to healthcare workers and the two Pauls for being here, but also healthcare workers, Paul Bemis, Paul Fredericks, for just being such champions on our behalf. Paul lives way up north, and he's been coming down to Concord to give testimony about this. So here we go with some events coming up. So New Hampshire Network is going to do the True Cost of Food with a farmer, Gene Jonas, of the Hungry Bear Farm, talking about what organic food is more expensive, but what you are getting and why you might want to make that extra expense. And next, here we go. We invite New Hampshire Network invites you to join us with all of our working groups. This event today was sponsored by Energy, and Paul is one of the leaders of our Municipal Energy Committee. They'll be meeting again March 21st, Wednesday at 3. And meanwhile, every Friday at 2 o'clock, Chris Skoglund gives real insight behind legislations coming up for the week. So that's always fascinating and fun to talk to him about legislation. We have a climate working group. We're meeting, I didn't update it. John Gage, what is the date for the climate working group next?
It's March 13th at 7 p.m. and you can go to newhampshirenetwork.org and click on the climate working group page to get the Zoom information. Thank you, Susan.
My apologies. Plastics will be meeting this Sunday, March 10th at 6, and our new environment group is meeting March 27th. at 5 o'clock. That is also a Wednesday, and they're sponsoring Gene Jonas with food. Anything that you need to know, go to newhampshirenetwork.org and you'll find all the links and the dates. We have a legislative spreadsheet that we update weekly and try and give you a lot of information succinctly so that you can give your testimony remotely or in person, or just press a support or oppose button. But come again to newhampshirenetwork.org to find out what the wise people that talk to us think about the bills coming up. And then here are the bills that Paul was talking about. 373 is just the Senate version of 1059 that he was talking about, upgrading energy code, building code, but leaving off energy. 1059 has yet to be voted on by the full House. So there really is time to yell and scream, and it hasn't moved over to the Senate yet. So your representatives may not know as much as you do now. So get on the phone, write them a note, and let them know why this is significant. And, you know, we're talking about more particulates than you get even with cars. And it's a matter, if we're talking about cost sharing and who it's fair to, a lot of people in apartment buildings have no say at all on how their house is built. So we want to keep utility bills down. That municipal energy code, whether or not they can exceed the more modest state ones, that has passed the Senate, and now it's going on to the House version of the executive departments. And just a shout out, healthcare workers put forward a bill, 496, Climate and Health Protection Program. That ought to pass in committee, and that will be facing the full House. So yay to healthcare workers. And today was brought to you
came
by
out of
the
the Senate committee unanimous. We were very pleased with that.
Yeah, it's just it's not going to be debated before the full Senate. It's just consent calendar. So we're the two groups that brought you this today, and here's the final word from the healthcare workers. Paul, if you want to talk, but I see the climate is changing. We can too. That's sort of a great words to think about.
Great.
And
Yeah.
last
Check out our website if you haven't already, New Hampshire, nhclimatehealth.org. A lot of information there. And one last time about the HEPA filters. I got an email from my utility company, Unitil, telling me about the opportunity, but that directed me to the NH Saves website. So if you're interested in a reduced cost HEPA filter, check out the NH Saves website.
Awesome. And come back for more. Join our working groups. Help us. Thank you. Thanks for being here.
Thank you all for joining us.
Thank you all, and thank you so much, Paul.
Thank you. Anytime.
Good night, everybody.